Okay, today I would like to share with you my experience training students and other participants in public health, informatics, and technology. This workforce development. What we found out that probably one of the ways to split the whole training in public health informatics and technology program would be first is the short training, which we call boot camps. And we separated students, participants in those who are undergraduate, they have only high school diplomas, and the working professionals. They can have masters, they can have bachelor's degree, and so forth. It is a boot camp for working professionals. So we need to separate because the curriculum is quite different from the undergraduate, from the beginners. Then we have baccalaureate, which is 120 credits, 4-year program. Then we have postgraduate certificate. It is 30 credits for 1-year program. Some universities do it for 6 months or longer. Then it is master's in public health informatics and technology. Some universities they have this program. And I would like today to focus on the so-called online training that we have experience working using this kind of module, this tool, and this is quite exciting way to train students. And I would like to emphasize online training today. When we talk about bootcamp for beginners, we've chosen the following module. We train them for 1 month. I know that some universities, they train for 2 weeks, 3 weeks. We train for 1 month because we have different categories of students. So it is 1 month training, 3 weeks. We teach them fundamentals of public health informatics and technology. And 1 week is a capstone project when students work on some problem. And what is the most important, they use real world program, real world data sets related to public health. And this is quite important because when students first see a large data set, they get scared. So we just train them that you shouldn't scare because we have algorithms quite efficient. They can be applied to large data sets without any problem. So that is one of the objectives. And regarding the fundamentals for beginners, we first we give them a kind of introduction and definitions. And from lecture 1, we ask them to install Jupyter Notebook, and we teach them some Python programming, because Python programming, it's not only Python is a language, programming language. Python programming also is a great optimizer of computations and therefore different operations. Therefore, it is quite widely spread now, widely used in healthcare and public health domains. The thing is that Python has very rich libraries that we also use, and students learn them and they use them in their capstone and hands-on training. Then we give them some knowledge on data sources. We give them knowledge on fundamentals of statistics. It is descriptive statistics, how to collect the data, integration of data with different formats and types, syndromic surveillance, electronic health records, public health data repositories, public health information system, privacy, confidentiality, and how public health informatics and technology can be used in health equity and mitigating health disparity. Then, of course, the capstone project basically focused on public health data exploration and visualization. Now, regarding capstone project, we teach them how they can use introduction to statistics that we train them for hypothesis testing using p-values in T or Z test models. Then we also they use the descriptive statistics that we train them in the first 3 weeks. And they do basically for beginners, they are focused on data exploration and visualization. In data exploration, they use partially Python programming, and they also Tableau prep. And for the visualization, they use also Python, and they use Tableau desktop. So that is what they do, and they can have data. They work with a large observation and many features. They do correlation analysis. They work with multi-feature visualization, and finally we teach them how to write reports. So they write reports, and they pass exams at the end of the 4th week of training. Now, regarding the statistics of the trained students, we have about 73-74% that were Afro-Americans. Then we have whites, Hispanic, and other. So this is like more we had from China. So that is the spread of our students' statistics. And it's very interesting that we have also a kind of substantial number of nurses here, those nurses who have experience in working in hospitals and so forth, but they want to change their specialization and include informatics and technology, so they become informaticians. So we have nurses, we have nursing assistants, then we have our undergraduate students, and we have also high school diplomas, those who graduated school, and they are interested in computer science, in the computer applications, in healthcare and public health. So we have this kind of split of the students we had in beginners, boot camp for beginners. What is interesting that we put advertisement online, and we had almost 45 students who registered, potential students, I would say that. So individuals who are interested in joining the bootcamp for beginners. What we found out that some of the students, they were a little bit uncertain about what they want to do in their lives and so forth. So we gave them second priority. So first priority we gave those who was interested in learning informatics and technology, public health, healthcare, and so forth. So that we gave them the first priority. And therefore we rejected about 12 students. So we took on board 34 students, and 3 students did not pass the final capstone and exam, so they withdrew. And then we had all together 31 students who graduated the bootcamp for beginners. Okay, now regarding the boot camps for professionals, it is also 3 weeks of fundamental training and 1 week capstone project. In FIT fundamentals, we had more profound, we gave them more information on statistics, on data sources in public health, digital epidemiology, public health information systems. And basically what was this topic, we had so many working professionals asked us to focus on data extraction from different sources and data exchange, basically. So we taught them public health interoperability. We introduced them to FHIR. This is one of the most useful now protocol for data exchange, and the use of web services or application programming interfaces, because the application programming interface is the same as the web services. So, yeah, so we teach them all these kind of things and how we use FHIR and API to move data from one point to another, and to store them in different data repositories. Also, we taught them introduction to big data analytics and cloud technology, which is quite quite important topics in public health informatics and technology program. So that is what was quite different from public health informatics and technology bootcamp training for beginners. So we basically focused on very practical information systems that now in high use, like FHIR API. Now, regarding the syllabus for working professionals, we had the introduction to public and population health, health equity, health disparity, statistics. We taught them descriptive and inferential statistics. Then we had central limit theorem used for data collection, hypothesis testing, introduction to epidemiology, public population health collection, bias, introduction to Python programming, then data preparation. And here I would like to say that we also taught them how to use Pandas data frame. Pandas data frame accelerates and facilitates all these computations when we have with the data pre-processing and so forth. Pandas data frame is a whole culture that do standardization, elimination of outliers, elimination of misfits, missing blanks, and so blank data and so forth. So inconsistencies, noise, and many things other. So it is pre-processing and does also, for example, this scoring for standardization or normalization. So this is Pandas data frame. Students now quite familiar with this, and they use it all the time. Now, we also used we also taught data integration, including, for example, social determinant of health, air quality, wastewater, social media, immunization registers, claims data, EHR, etc. Then in public health information systems, as I said, we had focus on different information systems, including registries and so forth. And also we include data interoperability, and the use of cloud technologies. For example, we taught them how to take the data from, let's say, EHR and move it to, let's say, MongoDB, so some clouds using FHIR API. Public health data repositories, we taught them SQL, NoSQL databases, data warehouses, data lakes, data lake houses, and migration, for instance, of data to data lake house or data lake, when we can integrate data with the different structures, semi-structures, unstructures. Then we introduced data science, outbreak, pandemic investigation, prediction modeling. Prediction modeling, this is quite important task that we also, I will discuss a bit later. The big data analytics, data integration, multi-stream data processing. So everything what actually they need in their work. And finally, the capstone project was pre-processing and processing of large volume of raw real-world public health data. So we used the data, they were raw, so there's lots of inconsistencies that required a very thorough pre-processing analysis and the use of these algorithms that we teach them how to pre-process the data. So capstone project, we focused on data integration and interoperability using real-world public health data processing. That is, we use as a data source HCAP. They had over 1 million records with many features, and we taught them how to do data exploration and population denominator and numerator identification. In terms of statistical analysis, they use t-test or z-test, depends, and basic statistical models. Plus, they use also linear polynomial and logistic regression as elements of machine learning. That is quite useful for processing the data and even pre-processing the data. And as I said before, we used basically Pandas data frame for all data calculation. That eased tremendously all data pre-processing and the processing using this library. So students now familiar with that and they use it all the time. Regarding, for instance, outliers, we see outliers very well on box plot. As a box plot, outliers are far from the lower or higher whiskies beyond the IQR, because this is where this data are concentrated. So that here is also, you can see them, that you can eliminate them using Python, for example. Programming is very easy, and you have the data ready for further analysis. Then we had, for example, in capstone project for working professionals, they calculated the different features, for example, using COVID patients analysis, and they built a model and calculated the p-value, which is very low. So all this model has statistical significance. That is quite important. Regarding data collection, we taught them how to analyze the data collected using center limit theorem and fitting the Gaussian function, the Bell function, to eliminate to mitigate the bias in the data collected. Regarding real world data, we used also a technique which is called also SVM, or support vector machine, that separates different outcomes. We use the hard boundaries, and we have soft boundaries to separate different events, and they calculated different features, and they used the feature engineering to identify features that do not play much role. Finally, they built a confusion matrix, which is that give a very high accuracy in data analytics using this, as I said, HCAP data. What I would like to tell today also about online training. Online training can be viewed as a supplementary to the boot camps, baccalaureate training, certificate, masters, and this platform appears to attract a large number of students. I would like to say that we start really online training in the fall of 2023, and we had only 50 students who were taking this training, online training. But this spring term that started in January, we have 147 students, so 3 times as many. We didn't expect so many students. So by the end of the year, we will have, I think, over 200 students trained in using this platform. Of course, we work with all of them, and this platform, we call it is fitusa.com. It has all kind of training using, for instance, here file server. So students who are who are taken on board, they just click on this and they have access to a file server or direct access to EHR. In HR, they are trained how to build HR, how to use different information technology algorithms to process HR, like, for example, natural programming language. And we have natural language processing, NLP. Then we have a training for beginners. They click on it. They have lots of material here. Then we have training for working professionals. We have advanced training in FIT. We have hands-on training. We have many examples of using Python for processing and pre-processing data. Then we have data sets. So it is like one shop marketplace when you have everything. So they don't need, for instance, to go to browse for different algorithms, and everything in here. Then we have capstone projects. So students who finished, for example, advanced training or training for working professional, they click on capstone project and they start working on capstone project. Then we have various codes already optimized, which is very handy. Python codes for processing real-world data set. And what we found out that some people who graduated our online training, they go to work and they use this platform because it contains many useful Python codes for their future work. Plus we have big data and cloud access to big data platform like Hadoop, Spark, and cloud like AWS, for example. We have this access to that. Now, for instance, when you just click on direct access to HR, they go to electronic health record and they can see examples of the use of, let's say, decision support platform that applied to different images. I'm not a doctor, I cannot interpret things like that, but that was processed using CNN. They're using image processing, using machine learning, deep learning, for example. Then we have here decision support that, for instance, process the data in different formats and gives some suggestion to the physician, for example, in terms of allergies, vitals, and so forth, prescription medicine, and so forth. So that is, students learn these things too, using this platform. And as I said, in fall 2023, we had a little bit more than 50 students who were taking our online training. And in the spring 2024, it's about 150. So together it is over 210 students in 1 year. They will take this course and will go for capstone and final exam on that. So it is quite efficient training. So students have lots of knowledge, and of course we supervise their training all the time. We have meetings with them, discussions online, and so forth. So this is quite an important element. It appears that it can be complementary to baccalaureate or master's or certificate and boot camps, but it is engulfs a large number of students, and of course this online training can be quite efficient tool for training public health informatics and technology. What is good that students come with different backgrounds and they choose what they want to learn. They choose, so they have lots of material and they choose it, and then we consult with us and we give them some ideas so to make their training complete. That is what our goal. What topics included in advanced training? The advanced training in fitusa.com focuses on applications of artificial intelligence, machine learning, deep learning, big data analytics, and cloud technologies to facilitate operations with multi-source public health data. So the users learn how to use open source libraries such as TensorFlow and Keras. It is for machine learning with high-level APIs to run high-level deep learning applications, Spark, Hadoop for big data, SageMaker processing to optimize computation, focusing on real-world public health data collected from different sources. To this one, they have all kind of Python-based algorithms that they use, and also they have lots of data and access to different open source platforms like TensorFlow and Keras with all explanation of that. So, and we have also two ways collaboration with students. They ask questions and we answer them. And also we have also online we have meetings with them on a regular basis, let's say once a week. So that is quite looks to be a very, very efficient tool to teach students. So what is conclusion based on is my experience? Maybe you have something else you can, so we can share. But this experience shows that online training can be an efficient complementary tool for feed training using feed data platform. We anticipate over 200 students will be trained using this tool each year. So each year we can be, this is what our data showed, 200 students can be trained. More than that is a little bit difficult because they have two-way training, so we need more faculty to work with them. Okay, so what the 200 students is a very realistic number to be trained each year. So boot camps can be efficient if they are split into two categories. So boot camps for beginners and working professionals, because beginners sometimes they have very, very initial background knowledge, and while the working professional already working on different areas related to public health informatics, and it has to be a little bit different program. Then we found that the Masters of Science and postgraduate certificate program can be also very attractive for those who would like to advance their careers in public health informatics and technology. That is the conclusion we made in terms of workforce development. Okay, thank you.